Hi, in this video we are going to learn how to route an inflow hydrograph using Muskingum channel routing. So this is what is given to us, inflow hydrograph. Delta T is given to us as 6 hours. We are also given K equal to 12 hours and X is equal to 0.2. So the first thing we are going to do is check the stability criteria. So again, delta T is equal to 6 hour, K is equal to 12 hour, and X is equal to 0.2. And the stability criteria that we have is 1 over 2 times 1 minus X less than or equal to K over delta T, which is less than or equal to 1 over 2X. So X is 0.2, so that becomes 1 over 2 times 1 minus X. So X is 0.2, 1 minus 0.2 is 0.8, K is 12, delta T is 6, and this is 1 over 2 times 0.2 is 0.4. So we end up with, so 2 times 0.8 is 1.6, so 1 over 1.6 less than or equal to 2 less than or equal to 1 over 0.5, 0.4 is 2.5. So the stability criteria is satisfied, so we are good to go. And again, if the criteria does not satisfy, we have to modify K and X. So in this case, we don't have to worry. Now the next step is to find out the values for C1, C2, C3. So we have C1 is equal to delta T minus 2kx over 2k1 minus x plus delta T. So delta T is 6 minus 2 times 12 times 0.2 divided by 2 times 12. 1 minus x is 0.8 plus delta T is 6. So this is 6 minus 2 times 12 is 24. 24 times 0.2 is 4.8. Similarly, 2 times 12 is 24. 24 times 0.8 is 19.2 plus delta T is 6. So what we have here is 1.2 divided by 25.6, which comes to 0.048. Okay, so that's our C1. C2 is delta T plus 2kx divided by 2k1 minus x plus delta T. So we have calculated all these values here. So on top we will get 6 plus 4.8. So it was 6 minus 4.8 in for C1. So for C2 is 6 plus 4.8 divided by 25.6. So this is 10.8 divided by 25.6, which is about 0.429. Now depending on how many decimals you use, you may get slightly different values. C3 you can calculate by using delta T and K and X, or you can say 1 minus C1 plus C2. I will still write down the expression in case if you want to calculate that. So this is going to be 2k1 minus x minus delta T over 2k1 minus x plus delta T. Either way you calculate, the answer is 0.524, and depending on how many decimals you use, you may get slightly different value. Since I'm using 3 decimals, this will be slightly, very little over 1, but that's okay. So as long as they add up and the values are close to 1, we are good. Okay, so these are the values we have. C1 is 0.048, C2 is 0.429, and C3 is 0.53524. And the expression that we have for Muskingum routing is Qj is equal to C1 times Ij plus C2 times Ij minus 1 plus C3 times Qj minus 1. And that is what we will do in this table that is given to us in our worksheet. Okay, so I will still write that down here. Qj is equal to C1 times Ij plus C2 times Ij minus 1 plus C3 times Qj minus 1. And then the initial condition is also given to us. So Q0 is equal to 10 meter cube per second, that is given to us. So let's say column 3 is C1 times Ij, column 4 is C2 times Ij minus 1, column 5 is C3 times Qj minus 1, and column 6 is our Qj. So Qj when j equal to 0 is 10, that is given to us. Okay, now let's only do 2 rows and then I will show you how to do this in Excel. Since our Qj for t equal to 0 is done, we will not do anything for this row. I'll just put dash here, and here C1 times Ij, our C1 is 0.048 times Ij is 20, and that comes to about 0.96. So 0.96 is our value for this row. C2 times Ij minus 1. So for Ij minus 1, we will use the previous row, which is this. So I'll just do an arrow here. So this will be C2 is 0.429 times 10. So this will be 4.29. Okay, and then our C3 is 0.524, and then Qj will come from the previous row over here times 10, so that comes to 5.24. And then we add 0.96, 4.29 and 5.24 to get Qj, which is about 10.48. Now as I said, depending on how many decimals you use for C1, C2, C3, you may get slightly different numbers than what I'm getting, but as long as they are close, I wouldn't worry too much about it. So let's do one more row and then we will try to do this in Excel. So C1 times Ij, so C1 is again 0.048. Since I don't have enough space, I'll just say C1 times 50 here, and that comes to about 2.4. This will be C2 times, again it will come from the previous row, which is 20 here, so C2 times 20, and that comes to about 8.58. This will be C3 times previous Q, which is 10.48, and that comes to about 5.5. And then we will add 2.4 plus 8.58 plus 5.5, and then we will get 16.48. Okay, so it's a straightforward process. All we have to do is get C1, C2, C3, and also check that the stability criteria is satisfied. Now we did 2 rows by manual calculations. Let's see how we can set this up in Excel. So this is my Excel sheet here. So again, K, X and delta T is given, inflow hydrograph is given. We can either calculate C1, C2, C3, or we can just get those from our manual calculation, but let's do it in Excel. So let's calculate C1. So this is going to be equal to, I will use parentheses, delta T minus 2kx 2 times k times x, and then divided by, I will use parentheses again, so divided by 2k, 2 times k times 1 minus x, 1 minus x. So that completes that parenthesis, and that parenthesis, and then we have plus delta t, plus delta t, and this completes the denominator. So I'm just going to push enter and make sure I get the same C1 that I calculated manually. And yes, so we got 0.048, and this, we have many decimal places here. Since we are going to use the same variable, so I'm going to put dollar signs for all these. So that's that, that's that, 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 that's that, and that's that. Okay, now just copy paste this for C2, and then I'll just change the numerator to plus sign. So for C2 we had delta t plus 2kx, and that, so, and for C3 I can just say 1 minus C2 minus C3. Okay, so this is similar to what we got, so we are good. Now let's populate the columns here for C1 times ij and C2 times ij minus 1 and C3 times qj. So let's say C1 times ij, so this will be C2 times ij minus 1, and then we have C3 times qj minus 1, and then finally we have qj. Okay, so qj, when j equal to 0 is given to us, so that's 10, we will write that down. And then let's do C1 times ij, so C1 times ij, this will be C2 times ij minus 1, previous row from the I column, and C3 times qj minus 1, so this will be C3 times q from the previous row. And since we are going to repeat this, so for C1, C2, C3 I will use the dollar sign. So this will be for C1, this will be for C2, and this will be for C3. And then qj is going to be addition of all these three columns. So this plus this plus this, and all we have to do is drag this down. Now if we want, we can continue this, at least for qj and qj minus 1, we can continue this until this goes to 0. Okay, so this is how we can route inflow hydrograph using Muskingum routing. What I can also do is I can plot this. So let's plot these and look at how they look. So go to insert, we need the line plot, and then let's add data. So series name will be inflow, values will be from the I column. Okay, and then let's add the outflow. So series name will be outflow, and series values will be, again, if I want, I can stop where the I value stopped, or I can take this to 0, and that's it. Okay, so blue is our inflow, orange is our outflow. If I want, as I said, I can delete this and this is what you get, or I can leave those values so you can see the outflow hydrograph until it goes to 0. Now I'm going to zoom in and show you something. So if you remember, for linear reservoir, our peak was falling on the falling limb of the inflow hydrograph. With Muskingum routing, the peak actually falls outside the falling limb of the inflow hydrograph. Let me zoom in more. So you can see that this is our peak here, and you can see the peak is outside the falling limb of the inflow hydrograph. Now this happens when the discharge and outflow has variable relationship. So in the case of linear reservoir, the discharge and storage has invariable relationship. In the case of Muskingum routing, the storage and outflow has variable relationship, and I'm going to explain what the variable and invariable relationship mean with regards to discharge and storage in another video. So for now, just remember that for Muskingum routing, the peak of the outflow falls outside the falling limb. For the linear reservoir routing, the peak falls on the falling limb. Okay, so this is all for this video. I will see you next time. Thank you.